Do not forget to subscribe and turn on the notification bell so that you can get updated every time I post a video. We are going to look at one of the questions under Newton's laws of motion. And the question says, find the tension in the spring, acceleration, and the time needed for masses to move 2.2 meters starting from rest. So this is the question that we're going to consider looking at. So we have been given this pulley having two masses, this one 10 kg and the other one which is 50 kg. So now we are told to find the tension in the cable, this one, or in the string, and also the acceleration as as the masses move 2.2 meters from rest. So covering some distance. This is the initial position. Now, Newton's laws of motion, or from second law of Newton's laws, we know that summation of forces must be equal to ma. So we have this one, since this is coming in this direction, so we have for m1, let us call this m1, and let us call this one m2. When this is going up, so the tension will be going in this direction. So we have a scenario such as this one. So we have m1g here, then we have the tension. So the summation of forces must be equal to ma. So we have tension minus m1g. This must give us m1a. So this one, let me write it here. So we have 2 minus m1g is equal to m1a. We call this as equation number 1. And for this one, since this is coming down here, we have mg, this is m2g. So meaning since it will be coming down, we are going to have t, so this is t. It will be m2g minus t. This will give us m2a. Let us call this equation number 2. Now, the way we are going to proceed, we need to proceed in such a way that we eliminate some variables so that we can remain with those that can help us to find the answer without having many challenges. So here we can eliminate, since we know that this, we have t here and t here, so we can eliminate t by simply adding. This is positive, this is negative. So if we add the equations, if we add equations 1 and 2, add equations 1 and 2, what we're going to have from the left, we have t minus m1g. Then here on equation number 2, from the left, we have plus m2g minus t is equal to, from the right, m1a plus m2a. So from this, we can see that this and this will go, and we can rearrange now this one, m2g minus m1g. This will give us m1a plus m2a. So this one, we know this, and this one and this one. So we can find a from this. So we can factor out a from this point by saying a, m1 plus m2. From this point, so here we have m2g minus m1g, which is equal to a, m1 plus m2. So from this side, g is common, so we can even factor it out, m1, which will give us a, m1 plus m2. Now, since we want acceleration, we can divide it through by m1, m2, m1 plus m2, then even here m1 plus m2, so that this and this will go, and what we're going to have is g m2 minus m1 over m1 plus m2. So this is the expression for acceleration. So now putting in the values, m1 is equal to 10 kg, m2 is equal to 50 kg, and g is equal to 9.8 newtons per kg. So plugging in these values in this equation, we're going to have, this is the g, which is 9.8 newtons per kg, times m2, 50 minus M1, which is 10, 10 kg, 50 kg, 10 kg over M1, which is 10 kg plus 50 kg. So from this, we're going to have 9.8 times 50 minus 10 is 40 over 10 plus 50, which is 60. What we're going to get here is, so this one and this one will go. So 6 into 9.8 times 4, we are going to get 6.5333, which can be rounded off to 6.5 units meters per second squared as the value for acceleration in the value for acceleration of the two blocks. Now, from this point, we can go on to find the tension by using one of the equations. So let us use either equation 1 or equation 2. From equation 1, we found that T is equal to T. So from equation 1, T minus M1G to find the tension, use either equation 1 or equation 2. So from equation 1, we had, okay, this is, we have T, then we have here mg. So we have T minus mg, since it is 1, m1g, which will give us m1a. So from this, we can take this on the other side. We're going to have T is equal to m1a plus m1g. Since m1 is common, we can even factor it out by saying m1a, then we have a plus g. Putting in the values for m1, we have 10 kg, then our a is 6.5, 6.5 plus the value for g, 9.8 newtons per kg, 163 newtons. So this is the value of the tension. Now, as it comes down, so we have this one, as it is coming down, as it covers 2.2, 2.2 meters, and it is coming from rest, we need to find the time taken. Which we do not know. So this one, we know that from equations of motion, we have x is equal to ut plus half a t squared. We also have v squared is equal to u squared plus 2ax. Then we also have a is equal to v minus u over t. But from the information that we have here, okay, also x is equal to, all these are the equations that we can use. Now, since we want to find t, in this equation, we have x, which is this one. We have u, since we are told it is coming from rest. Initial velocity is equal to 0, so we have u. We have a, yes, we have found the value of a. Then we want to find t, so we can use this one. What about this one? Can we use this one? We do not have this, so we can't use this one. And here, yeah, this one we do not have it, so we can't use it. We can't use also this one, but we can use this one. So we're going to work with this equation with the first one I've indicated here. So we have x is equal to, from rest, this is 0, plus half a t squared. So here we have x is equal to half a t squared. So we can multiply by 2 and also by 2 here, so that this and this will cancel. And what we're going to have is a t squared is equal to 2x. So we can divide by a, we can divide by a, so that this and this will go, and we're going to have t squared is equal to 2 times 2.2 over 6.5. So here, what we are going to get is 4.4 over 6.5.